Hello, everyone. Nice to see some faces here in the crowd. My name is Saha Lemanchek. I'm managing partner at the consultancy firm Bluk, and I'm very happy to be the moderator of the second innovation session today. I am very personally interested in the speaks that we are going to hear, and looking forward to them, to all of them. And to me personally, the answer why innovation is relevant is, to me, it's fun. I'm very curious person. I like to learn about new things, and I embrace change. But to the industry, I don't believe that all of you share the same attitude as myself. You might be interested in other things than innovation. But why this still is relevant to the industry and to all of you, I believe, is that the future is going to be a more connected, more digital, more automated, and also more sustainable one for the industry. And we need to use innovations and incorporate innovations in our work in order to achieve this future. So with this said, I welcome the first speaker to the stage. The first speaker is from Awake AI, and his name is Jussi Poikonen. And he is the Vice President of AI and Data Analytics, and he will be presenting about how AI can help in transitioning to sustainable maritime logistics.
Thank you very much. Also very happy to be here today. I think this session is personally very interesting for me. I have originally a background I did my PhD in wireless communications, which we are talking about today. I was leading AI development at Rolls-Royce for autonomous vessels, and we are talking about that kind of devices or robots also today. And of course, at Awake AI, we are developing AI solutions and cloud-based AI software, which is another relevant topic. So without further ado, let's just go into the discussion. I'd like to say a couple of words about Awake AI first to introduce who we are. So we are a startup developing a cloud-based smart port as a service platform. This provides services and tools for port digitalization, data analytics, optimization, moving the industry forward in a digital way. And fundamentally, we are trying to solve many of these sustainability issues in the industry and shown also here. Of course, it's a big challenge, but we believe that these kind of AI solutions can really help in solving some of these problems. And today, I really want to give some concrete examples of the AI solutions and services that we have been developing, some kind of new novel services, hopefully give some food for thought for you, and I'll get to those at the end of the presentation. I wanted to collect here a kind of summary of these different AI applications in the maritime logistics field, divided by a couple of different dimensions. So, of course, you have separate solutions for the sea, port, and hinterland in these different kinds of application domains. And these are typically from the edge solutions, so AI running on site towards the cloud, so everything is running somewhere and you're transmitting information between the systems. And of course 5G and these new wireless solutions are a big part of bringing all this together. So hopefully this kind of summarizes a little bit this whole topic of the session. And of course, our interest is in the sustainability aspect. So the question is, what can AI do for sustainability? And of course, there is not one single answer, because sustainability is a very difficult and large topic. It depends on talking about economic, ecological, technological sustainability. But AI applications can introduce safety, kind of automation, more efficient operations, awareness on what's happening in the logistic chain, and of course improved collaboration and cooperation between parts of the logistic chain, better planning and reducing emissions. with that in mind, these are still kind of fluffy words, but I will get to the examples in a few minutes. We have been working on a lot of different services and applications on these topics, and let's look at a few of those soon. Now, about the role of AI and sustainability, I think it's interesting to think about AI applications as a means of encoding and bringing sustainability, let's say, policies to day-to-day planning. So by building these kind of systems which actually try to bring, for example, information on emissions or economical problems to the use of a planner, for example, planning, let's say, a port call in a port. This is the first step in really kind of driving sustainability according to preset metrics and policies. And the next step will probably be that some of these decisions will be automated. So perhaps the AI elements will start providing prescriptions and kind of saying, to optimize your emissions during this port call, you should choose this and this timings for the vessels, and so on. So I think it has a crucial role in kind of improving sustainability, but it is not really a silver bullet, and we need to go through the current operations and more like augmented intelligence than just trying to automate everything right away. All right, at Awake AI, we develop a lot of different AI applications. I won't read through this list, but I want to show next a few examples of these kind of practical applications and kind of, let's say, novel AI applications that we have been working on lately. So the first one is related to remote pilotage, and this is related to a project that was actually demonstrated just a few weeks ago in collaboration with the Finnish pilotage provider FinPilot and ESL Shipping in Finland. And what we developed for this is an AI system which calculates these kind of safety margins for navigating these kind of, let's say, hazardous fairways like this one in front of Helsinki. So the idea is that the system gets the vessel's current location, movement dynamics, wind speed, currents, these kind of things which affect the navigation, and displays these kind of safe borders for the vessel. So if you go further than this with this current without changing anything, then you will go outside of the fairway. So this is a kind of example of safety and going towards really remote operations and autonomous operations even. Then the second example is in automating monitoring and analysis of operations and events in the port. Specifically, in this case, we are looking at or visualizing the actions of 4 tugboats in Southampton, UK. And the idea here is that we can actually automatically classify what the tugs are doing over time. We can identify when they are assisting vessels, what kind of assistance they are giving, when they are, just resting at berth, when they are transiting to operations and so on, and give this kind of analysis or breakdown of what the tugs actually do. So this is a case of really automating something that is very manual and kind of a lot of work to follow these, and kind of humans are compiling this stuff and enables this kind of digitalization and connecting this information to digital systems. Also, this enables us to model the services needed by vessels visiting the port. So the idea is that we can then predict, for example, how many tugboats a given type of vessel will need in these conditions to safely do a port call, which enables then to optimize this resource planning for the towage company, for example. Then, can I ask how much time I have? Well, okay, I will skip this example. So my third example is about vessel schedule predictions. And especially the problem is that many actors in ports have very poor visibility on future schedules related to short sea shipping. So if you only get information about the vessel when it has left the previous port, then for short sea shipping, of course, you can get the information quite late. And this is really a practical problem for planning. So what we have done now in collaboration with the Finnish vessel traffic services provider FinTraffic is implement this kind of multi-hop prediction service, where we collect port call plans from many countries, let's say all ports in a given region, and then we connect these with our vessel travel time predictions, and we can then continuously monitor, all the expected arrival and departure schedules, many port calls into the future over a whole region, which significantly improves or can improve this kind of visibility to the future of short sea shipping. This is currently operating commercially in the Baltic region, and we are kind of looking to expand this to, let's say, Central Europe next. Of course, this involves a lot of integrations, but I mean, that's the kind of cost you have to pay to implement this kind of thing. Then, as a final example, this video illustrates a predictive simulation system, this kind of AI system, which aims to model or predict the truck traffic generated by port operations. So the idea is that we monitor vessel movements globally. So in the top right, you see this kind of vessel route predictions. We can predict, say, a week or two ahead the arrival time of a vessel. Then we have modeled these cargo dwell times in the port. So when the vessel arrives, there is a certain distribution of time that the containers take getting out of the terminal and being picked up by trucks. And by combining all of these models, we can produce these kind of simulations several weeks in advance of these kind of, let's say, traffic rates out of the ports. And this is, of course, useful, especially for this kind of, let's say, multimodal optimization. So it's important for the city to understand, for example, if there will be a big spike in truck traffic out of the port a week or two from now. So they can prepare their traffic management systems for this. This has been implemented in collaboration with Port of Valencia, or the Port Foundation of Valencia, and Port of Livorno as part of a EU H2020 project called Ingenious. And the main goal here is to also then optimize the truck turnaround times in the port, if we can really predict these variation in the traffic rates. All right, that was a really quick overview of this kind of new AI cases that we have been working on. I would be happy to talk more about this. If you have questions, we have a booth at the other side of the hall. Thank you.
Thank you very much. That was very, very interesting. And if we have questions from the audience, I wanted to let you know that we have a Q&A session at the end of this session, so after all of the speakers have had their presentations. Unfortunately, the next presentation we need to skip due to unforeseen events, so I will directly go to our third speaker on the list, who is Lasse Eriksson. He is the Vice President of Technology at Kalmar, and he will talk about a new era of robotics, container handling in mixed traffic. Give a welcome to Lasse.
Thank you so much. Great to be on the stage again in front of real people, so wonderful experience. A little bit of extra excitement, of course, due to that, but good to see you all. Thanks for joining the session. As said, I will be talking about robotics and especially how that, of course, will change the container handling automation in the future. So, talking about automation and robotics, so automation, as we know, has been applied, of course, throughout the industry in a big scale. In several instances, we have seen implementations of cranes, and we've seen implementation of horizontal traffic, including straddles and shuttles and AGVs throughout the years. Some deployments on STS cranes or key cranes as well on automation. And this is kind of everyday life to us, I guess. But what we haven't really seen so much is on the right side, which is more about the kind of the smaller terminals, smaller, let's say, deployments and applications of mobile equipment, where automation level is still relatively low. There are very few real-world deployments of automation in that context. And why is that? One reason is definitely that let's say the load handling or material handling tasks that these types of equipment are doing is fairly complex and varies quite a bit. So it's also very difficult to automate as such. But it's also that the environments where we are operating with these type of machines, they are also quite many. So it's much more or much less controlled environments where we are actually operating with these ones. And very often you face these type of machines in same environments where you have actually people and you have other vehicles operating in the same area. So what we see there as an opportunity going forward is definitely to look into bringing more of the, let's say, intelligence or sensing capabilities, calculating capabilities, and actuation capabilities actually to these equipment rather than having only the let's say central control for automation solution. And that's why we will be talking about robotics in this session, because this robotics technologies is a key enabler actually for bringing autonomy basically to these equipment as well. So some comparison between automation and robotics still before we continue. So first of all, these are not like competing approaches as such. So these can actually, automation and robotics coincide very well in the same field. But as I explained, robotics capabilities basically mean that we bring much more of the intelligence in terms of sensing capabilities, calculation and computing capabilities into the equipment. And this actually allows then us to do, for instance, navigation and localization positioning of the equipment in a different way than in the traditional automation setup. So these sensors typically can of course measure the distance to any obstacles around the machines, but they can also help to kind of actually position the equipment very accurately in the environment where it's operating. And this has an impact on the kind of what do you need from the infrastructure perspective for localization, for instance. So obviously we see opportunities to bringing this technology into deployments where we have a fewer number of equipment, and we should not only consider automation as an option for bigger deployments. Another perspective to this is definitely safety. So of course we are seeing that these sensing capabilities can also prevent the machine from colliding with anything around it, including dynamic obstacles, humans, as well as then service vans, for instance. So we bring a little bit more of the flexibility to the operation. We don't necessarily need to stop the operation always if we need to kind of interfere with the machine on the site. So there are a couple of differences in the approaches here that we see. Robotics definitely is technology that also kind of applies to different applications, different segments of industry. So not only ports and terminals, but of course we as Kalmar, we're serving also, for instance, distribution segments, forestry, metal, etc., heavy industries. So it's in our interest to develop generic, let's say, technology that applies to much more of our customer segments. And in robotics, we see a lot of good synergies across these segments, even if the machines are doing a little bit different tasks, different material handling tasks, and they operate differently. But still, the basic technologies can be shared. And this is good for the technology development, synergies, speed of development, etc. When I was thinking about the robotics, I couldn't help of thinking about the progress in this area. And I like to use the example of when we talk about the speed of development on the left side, which is 1997. I believe every one of you were born already by that time. So you may have seen a James Bond movie around those times, and if anyone remembers the scene where Mr. Bond was actually hiding from some of the bad guys who were kind of shooting at him, etc., he was taking his cellular phone and actually connecting with the nice BMW and doing the remote operation with the cellular phone from there on. And he actually jumped to the car while he was kind of remotely operating it through the open window and back to the back seat and continued driving from there. So that was 1997. It was a visionary. It was a kind of nothing that you can buy from the shop, so to say, but the kind of a visionary, the best thing that Q, the CTO of MI6, could offer at that time. And that's 25 years ago, right? But today, if you look at the kind of the automotive sector, for instance, and you go and buy your new Tesla or other premium brand, so you have all these autopilot functionalities, auto-driving functionalities actually within in the cars. And this is the kind of the maturity step that has taken place in 25 years. Of course, we are not doing fully, let's say, autonomous driving on commercial vehicles today, but I mean, the speed of development is anyway pretty fast. And why this is important for us as well as industry, it is because this technology is applicable to our types of machines, mobile equipment as well. And it's of course good that the automotive industry is putting some tens of billions of euros or dollars every year for the technology development, for sure. And that brings me to a little bit to the maturity. Where do we stand on this journey? I used the SAE kind of definition for autonomous driving and the levels of automation as such. And on the left side, in the level 0, basically, we have some warning systems, and that's the maturity there. But on the right side, full automation basically means the vehicle can autonomously fully drive anywhere, in any conditions, any surprising events, without any interference, or it does not need to be taken over by the human being, basically. So today, I would claim that in our industry, we're somewhere in the, let's say, level 3 automation. We see deployments, we see pilots of autonomous mobile equipment that are meeting basically the requirements and of the level 3, which means basically that the machines can operate autonomously in given circumstances, but not if something unexpected kind of happens. They need to be taken over by remote operator. I would say level 4 is something to aim at in our industry. That means basically that we can also dream of and see actually those kind of machines that you see in the background picture without the kind of the cabin or the place for the operator in the machine itself. So the level of maturity is very high. The machine can operate very much autonomously actually throughout the process in the given circumstances. So that is still some years ahead, I would say, but in general we see good development happening towards that level of maturity. And we are not alone in this industry. As said, automotive is very much pushing for autonomous solutions. But you see the same thing, of course, happening on the trucking side. You see it in the mining side. You see it everywhere, wherever we have heavy machines or heavy vehicles, basically that will need definitely autonomous driving capabilities going forward. And if you look at these examples, or you look at examples from our industry, what I generally see is that we're very much in the kind of the piloting phase still, in the different kind of demonstrations with this technology today. But within, let's say, 1 to 2 years, we for sure see this maturity development taking steps, technology becoming more affordable, and also the kind of the commercial viability becoming better and better. And then if you look at the latter part of the decade, 25, 2030, we see the wider deployment of the solutions and the commercial viability even improving going forward. So that's why we are also at Kalmar looking at the new era of robotics. And what we have done so far is we have introduced the kind of a Kalmar robotic portfolio at the end of last year. we are definitely working on all these different types of solutions for robotics, starting with Kalmar Robot Tractor, which is our autonomous terminal tractor, obviously. So development is ongoing. This is not like commercially available today as such, but development is ongoing. We are working with our customers on different pilot cases, on different applications of this one, and definitely looking into taking this to the market in a wider scale going forward. But I would like to close by showing some concrete example of how does this look like, and I'll take our robot tractor as an example here and show how that is actually operating then in our customer sites. Can you run the video that should be embedded on the... So in this case, we are definitely utilizing the capabilities of the tractor itself to do the localization, the positioning, the control, as you can see, of the machine, and taking it through certain paths in our customer premises in this case, and doing the trailer handling, of course. And this is a little bit how it looks from the kind of sensors point of view. That is the information we utilize in order to actually position the machine, and of course to avoid accidents, as we can see on this example. So this is technology that will take us ultimately to the phase of mixed traffic scenarios, and this is something we're fully focusing on at this moment. So thank you very much for your attention, and happy to talk to you more after the session. We'll have a demo session also at our Kalmar booth at 2:30 today, so happy to host you then as well. Thank you so much.
Thank you very much for this very insightful presentation. My next speaker will join us virtually due to personal reasons. He couldn't attend this TOC event in person and is hopefully soon able to be seen on the screen. I can do a quick introduction. I'm sorry. His name is Sander Rottmansen, and he is the head of wireless solutions at Siemens, and he will talk about industrial 5G compared to existing 5G standards and Wi-Fi 6E mesh.
I assume you can hear me. Sorry for not being there. This virus got me last week, and I'm not allowed to travel. So therefore, I'm joining virtually. I hope that's okay for you. It's the same slides, it's the same talk with slightly less voice, but we'll go through it. So let's start with Industrial Wireless Lan first. So Industrial Wireless Lan is a technology which is actually very much used in your industry as among other industries since almost 2 decades. So for example, we launched our first Industrial Wireless Lan product already in 2004, and since then we have been steadily developing our products towards Wi-Fi 6, Wi-Fi 5, and since recently also Wi-Fi 6. These technologies are very focused on us as a consumer. However, we got a little bit more out of it by utilizing our eye features. But with Wi-Fi 6, for the first time, there were also things addressed which were interesting for us in industry. For example, we have OFDMA, Enhanced Power Save, which is, for example, very interesting if you want to let a device sleep. So not only can you let your Wi-Fi device sleep, but with smart devices, you have a digital input, digital output. You can also let the whole AGV sleep, for example, which is useful if you have a battery-operated solution. Spatial reuse helps you to have different devices communicating on the same channel. This allows you to have a better signal quality as well. And then we have Downlink and Uplink multi-user Mimo, which combined with OFDMA allows you to have a better, more robust communication technology. So with OFDMA, for example, for the first time ever, it's possible that one access point addresses more end devices at the same time. Based on the standard, this is up to 9. So this is a very exciting technology because this helps us getting a more real-time solution from a technology standpoint. So looking at all of this sounds already very interesting, but unfortunately, Wi-Fi still hasn't all the answers in the standard. So there were things done, yes, but there is still things which we need in an industrial network setting, like a deterministic solution. We need to have improved roaming, for example. And this is where we come in with so-called I features, as we call them at Siemens. These are enhancements on top of the standard, ensuring that we are able to really address the pain points or the challenges we have in an industrial setting. And so this is very important to look at. So Wi-Fi 6, it's better already, but it's not fully there. Therefore, these I features will help in the future. So, but I was also going to talk about industrial 5G. So with industrial 5G, we're talking about a 5th generation wireless network. And what is so special about this? The special thing about this is that it's the first time ever that a mobile wireless network, a cellular standard, was developed with industrial use cases in mind. So how did this happen? For example, in 2016, we as Siemens joined the 3GPP, the 3rd generation partnership project, to ensure that the requirements we have from our shop floors, from our terminals, from our utilities, from water, wastewater plants, from you name it, were part of the standardization of the 5th generation wireless network. And it was not only Siemens, there were more companies involved, but this helped us out. And it's not like we never used 2G, 3G, or 4G technology in the past in industry, because we started with 2G already when we learned a PLC, a controller to send text messages. Very useful in water, wastewater networks, for example. With 3G, we were able to join, to access a PLC or a SCADA system remotely. With 4G, we could even add video data to this as well. So we had visibility on what we were changing live and remotely. And with 5G, we have the ability to do a little bit more, because this was really developed with industrial requirements in mind. So looking at that, when we look at the 5G development, how did this turn out? So we looked at this triangle. The triangle has 3 cornerstones, of course, as usual with a triangle: a data rate, number of devices, and latency reliability. All very interesting. So I can have a high data rate. So we're talking about 10 to 20 times faster as with 4G. So peak data rates you read in the press are 20 gigabits per second, which is amazing. But I've never seen a robot or an AGV utilizing that much data. Then we have massive machine type communications, where we talk about the number of devices connected. We talk about 1 million connected devices on a square kilometer. It is an amazing amount. So if you have such a large amount of devices to connect, call me. I will give you my phone number and we'll help you out with some end devices. But also we talk about ultra reliable low latency communication at the right lower corner. And this is where actually I'm most excited about, or the industry is most excited about, when we talk about industrial 5G. So I have high bandwidths, I have a lot of devices connected, and I have low latency with highest reliability. So this sounds like the solution. This sounds even better as a wire. But what no one actually tells you when we talk about marketing solutions is that it's either or. Meaning you can't have the highest data rate combined with the lowest latency with the maximum number of devices. And this is where those profiles on the left and right come into the game. The public profile, for example, is the network we utilize ourselves. So if I will be online now with a 5G smartphone, I will be focusing on a high bandwidth because I want to make sure that I have a video call at the highest quality. I want to ensure that I download my Netflix movies, Disney Plus movies, or whatever streaming service you use as fast as possible. And I want to do this with as many people as possible at the same time. And I don't really care of that if a text message comes in now or in 10 milliseconds or in 100 milliseconds or in 500 milliseconds, because my own reaction time isn't that fast. However, when I talk about an emergency stop at a shop floor, and I want to push that one, and I want to ensure that my AGV or my RTG is stopped at the right moment in time, that is exactly what I want to expect from a 5G wireless network in the future. It also means that I cannot have the highest bandwidth, and I cannot have the maximum number of devices connected. So I really need to choose how my network is going to be set up. And to do that, in 5G, there is multiple deployment scenarios. Because of course, if we talk about the network on the left side, the public deployment, we talk about a deployment of a network which is already there. We use it every single day. Many of you probably are holding cell phones right now in your pockets, maybe even in your hands, and you're actually utilizing the network as it is. So this network is laid out to entertain you as an end user, and we just abuse it for other stuff when we are talking about industry networks. This is where private networks come into the game. You see them on the right side, where you have the control and user plane on site. So what is a control plane? What is a user plane? Control plane is the network management data. Are you allowed to talk with the network? Are you allowed to roam? With bandwidth can you roam? Do you still have data in your contract? And the user plane is the actual data you utilize. And this is something you want to keep private because you don't want everyone to have access to your data. Imagine everyone knows how many containers you are moving or how many kilometers your AGVs are driving or RTGs are driving at your container terminal. This is, I think, data you want to keep for yourself. So this is where the private network comes into the game. So therefore, these infrastructures are really, really important to look at. And it's not like public deployment is not interesting for industrial use, because when I talk remote service, remote maintenance, this is absolutely interesting for me as well. So where do we actually stand with this 5G? Because I hear it everywhere. I see advertisements when I take the bus or when I take the train or when I'm just driving my car. I see signs like 5G is here, 5G is now, 5G is happening, 5G is €5 more expensive as a 4G contract. I see it everywhere. But in industry, we seem to be holding back a little bit. So why is this? Because 5G is not 5G. 5G comes in different releases. Where we talk about Wi-Fi, we talk about Wi-Fi 4, Wi-Fi 5, Wi-Fi 6. With 5G, we talk, or with cellular communication, we talk about releases. And 5G started with release 15. 1 to 7 was 3G, 8 to 14 was 4G, and release 15 was the first 5G standard. So that was released in December 2018. So just looking at my clock, that is about 3.5 years ago. Almost 3.5 years ago. That's a long time ago. So, and here it says release 16, July 2020. But if you look down at the table, you see partially, complete, none. So what does this mean? 5G comes in different chunks. So first they focused on commercial public networks. With release 16, they focused in the standard on private networks for industrial challenges. And it's addressed in the standard. So now we have 10,000 pages of paper, which we can look at, which is amazing and which is great. But that's just paper. First, we need to create products out of it. And creating a product out of a standard takes roughly 2.5 to 3.5 years. And you think that's an awful long time, but just look at it. December 2018, release 15 was done. Someone put a stamp on it. Approved. The first iPhone with 5G came to market at the end of 2021. First industrial devices hit the market early 2022. Our products, which you can normally see behind me, are available since June 2022. So we are very early, but we're still waiting for future releases to be made into real products. Also, a very important effect of wireless networking is spectrum availability. I think a lot of people on your side have issues with spectrum availability, meaning that they have channels being used for maybe IT applications where they actually might be better to be used for OT applications and vice versa. So one of the great things about Wireless Lan is that there is coming additional spectrum. We get, depending on the region where you are, up to 1.2 gigahertz of additional spectrum. I think it's just over 1 gigahertz in the United States. In Europe, we're talking about 550 megahertz additional, which definitely makes it easier to set up modern wireless networks, especially because this only started with Wi-Fi 6. So I have a greenfield deployment. I don't have to look at already installed base from Wi-Fi. I can really start new. So this is really exciting for us as well in industry to see what we can really do with a clear spectrum. And with 5G, we talk about private spectrum. We talk about having private spectrum available. Private spectrum is important to set up private networks because without spectrum access, I'm not allowed to do this. So currently we have roughly 15 countries in the world which are already dedicating spectrum to private wireless networks, as well as there's lots of countries still contemplating. For example, in Europe, they're contemplating on having harmonized spectrum solutions based on 3.8 to 4.2 gigahertz as an additional spectrum for 5G, where many countries could then use this spectrum for private wireless networking. So talking about products a little bit, I mentioned it already. So we do have Wi-Fi 6 products available currently on the market. So here you see an access point or a client. These are put in our standard housing. And now I click one further, you see the same housing again, and these are called 5G devices. So we went as far to design one form factor where we fitted in Wi-Fi or 5G. So you could actually, as viewer, supplier, and OEM, you could design one mechanical device and say, like, which flavor do you want? Do you want to have strawberry, or do you want to have vanilla? Or in technical terms, do you want to have Wi-Fi, or do you want to have 5G, or do you want to migrate maybe later to 5G? This is easily done by just switching out one component. And we went as far as even looking at our antenna portfolio, which covers both 5G and Wi-Fi 6 with the same antennas for private networks and in 2.4, 5 gigahertz, 6 gigahertz, and the private networks band currently known on the market. And we as Siemens go a little bit further as just end devices. We are currently the only OT supplier in the world who is actually working on creating their own 5G private network solution. So here we have it installed in our Siemens Automotive showroom and test center nearby where I'm currently in Nuremberg. And here we are already testing since end of 2020. And this is a solution we plan to launch in 2023. So if you're excited in learning more about 5G, either come to the Siemens booth or connect to me personally on LinkedIn or by email. Unfortunately, I'm not part of the Q&A due to technical limitations, but I'm free for questions directly through LinkedIn or email at this moment. So it's back to Rotterdam.
Very good. Thank you very much for this presentation. And as we already heard, Sander will not be available for the Q&A, but you can absolutely feel free to address your questions directly to him or to the TOC team, and they will pass it on, whatever you prefer. So our next talk is on a topic that is also very, very interesting. And the speaker is Thor Thorup from Portchain. He is the CCO and founder. And he will talk about the need for coastal schedule alignment between carriers and terminals through trusted data sharing in a post-pandemic world. Give a warm welcome to Thor.
Thank you very much. Great to be here. So I'm going to talk a little bit about how to make just-in-time port calls a reality. And in Portchain, we believe that is through, as it says here, schedule alignment between carriers and terminals through trusted data sharing. So a brief introduction to Portchain. So Portchain was founded 5 years ago. Myself and 2 colleagues, we were working in McKinsey, seeing a lot of challenges, especially in the interface between carriers and terminals. And that's why we founded Portchain. And really the problem that we're focusing on is really in that intersection between carriers and terminals and that interface. So we're really focusing on the inefficiencies and the waste that come from both lack of and poor data, poor planning, and poor collaboration. So how do we actually work on this problem? So we have 2 products today, and we'll be talking about schedule alignment, which is Portchain Connect. And this is really for carriers and terminals to actually come together, align their berthing windows, and create a digital handshake on the schedule. Second product is Portchain Key, and that's really for terminals and ports to both align and plan their berth, their quayside, optimize their cranes, their gangs, etc. And what's common to the way we approach these problems? It's really sort of a 3-step process. So step 1 is really how do we create visibility? So that's bringing all the right data into an easy-to-use format for an operational team. Second, we all know that a lot of data is not always that accurate in our industry. So that's where we use predictions, machine learning to basically plug the gaps, make that data more accurate. So now you have good visibility, you have good data. What do you do with that data? You need to align it. You need to make sure that both your internal partners, internal stakeholders, but also your partners have an aligned plan and know what's going to happen. So today we're going to be focusing more on the connect and the digital handshakes. So let's see here. Okay, so just to sort of zoom out a little bit. So many of you have probably heard about just-in-time port calls and what value it can bring to the industry. And recently, the IMO, they were out with a new study where they basically had looked at a lot of container vessels, basically all container vessels for a full year, looked at how they were sailing, are they waiting outside ports, and identified what would be the opportunity if you started implementing just-in-time port calls. And based on all of that work, they came to saying, okay, around 6% of bunker could be saved and CO2 could be reduced through the implementation of just-in-time port calls. So that's great. That's a great potential. But how do you actually make that work in practice? So diving into the process, what actually goes on, how can you actually enable these just-in-time port calls? Let's see. Yeah, so that's really where the berth alignment problem comes in. So today, when a vessel is arriving in a terminal, you have basically from both sides, terminal and carrier, information sharing going through phone, email, spreadsheet, sometimes EDI. And it's a very manual process, very people-heavy process, very time-consuming process. And as you know, with all the disruptions we have today, once you have a delay in one port, that will cascade further to another port. And you need to repeat the process all over again. Why is this an issue? It's an issue for carriers because they'll end up either being there too early, having too much waiting time, not being able to capture opportunities in the network. And for terminals, it's costly. They won't optimize their berth, they won't optimize their gangs, they won't optimize their crane deployment. So this is really, you could say, a root cause foundation of many issues in the industry. So it's inefficient, and that's what we're trying to do something about. So I want to give you a brief introduction to Port Chain Connect, and that's best done through a video here. So let's see if it works for us here.
The global supply chain is experiencing disruption after disruption, from port closures and the lack of trucks and warehouses to rampant port congestion and low schedule reliability. At the heart of the supply chain, container carriers and terminals are struggling to effectively align berthing windows, relying on cumbersome processes based on spreadsheets, emails, and phone calls. Berth alignment has never been more important, as delays in one terminal cascade to the next and create knockoff effects for everyone involved, costing the industry billions of dollars every year. Introducing Port Chain Connect, an easy-to-use berth alignment solution that connects carriers and terminals to the latest schedule, providing you with the latest information needed for faster alignment. With Port Chain Connect, you can plan with confidence, stabilize your berthing windows, and identify issues before they occur. From digital handshakes with your partners on berthing timestamps and expected move counts. Streamline your processes with easy integration options and take advantage of smart arrival predictions with the knowledge of vessel routing and waiting times at previous ports. Terminal carriers across continents are already benefiting from Port Chain Connect today with faster alignment, more accurate planning information, and more streamlined processes. Port Chain Connect is the berthing alignment network of the future, with more users coming on board by the day. Are you ready to connect? Setup is quick and easy. You can be live with Port Chain Connect in just a few weeks. Request a demo at portchain.com today to take your operations to the next level.
Okay. So how do we make this work in practice? So I think there's two key things that we're doing that we believe is quite important to achieving this in practice. So the first one is actually having a handshake. So this is really where, and we're also leveraging the DCSA standards here, is that we've implemented the negotiation workflow around timestamps. So basically from a carrier providing an estimated timestamp to a terminal providing a requested timestamp, and then when those two come together and they align, that's where you have the handshake. That's where it's the planned and validated time that you can trust and plan your operations based on. The second part is, how do you get trusted data? How do you get the most high quality data to stabilize your berth window? And that's really where we both augment system generated data with also user generated data from the users who are actually making the decisions. So that's being berth planners on the terminal side, be it line, agent, or cargo planning on the carrier side. So bringing them all together, having one place to view the port call and align on that data. So just to give a brief overview, where are we today? So I think one of the key things is that we need to really enable this in practice, you can't start with saying, okay, we need a one-year implementation project. We need to make something that's quick, you can get up and running quick. So in the last 6 months, we've connected 17 terminals. And one of the things is there that we can really get started very easily, even without connectivity. And then once they quickly see the benefits, we can connect them also to their system. So I think so far, we've sort of seen three main benefits from our terminal users. So one is increased data quality and frequency, and basically just speeding up that whole alignment process and giving them better data to plan from. Second is around just saving time and effort. So just getting away from the phone calls and the emails, the constant follow-up, which of course at a user level can be quite frustrating. And the third and most important is actually getting an increased alignment. So having a more stable birth window that supports the birth planning, the schedule planning. We're an open platform, with Hapag-Lloyd being the first carrier to deploy in its network, and currently we're working on onboarding other carriers to it. So if you want to learn more about Port Chain Connect, you're very welcome to visit us at our stand down there. We'll also have Andrew Allen from Terminal Partnering from Hapag-Lloyd, who will also be joining to answer any questions specifically to the way Hapag-Lloyd is also using it. Thank you.
So this was our last presentation, and I invite our speakers to the stage so that we can have our Q&A session. Very good. So we've heard presentations on various topics, all of them very interesting, and I am looking forward to questions from the audience. So if somebody in the audience has a question, then please raise your hand and we will facilitate your questions. If you still need some time to think about your questions, I've prepared some of my own in the meantime. Yes, so I think my first question, just because it was the last presentation I heard, is you mentioned in your presentation, Thor, that the setup time of Port Chain Connect is very short. So we are talking about a couple of weeks. In my experience in industry, setup times, integration times are much longer than that normally. So how did you achieve this?
Yeah, so that's really where we offer quite some flexibility. So actually we can set up, you could say, a new terminal unconnected to their TOS. So it's not connected, it would be 1 day. And then that's where we would then offer them, once they start using it, they see the benefits. They replace their manual process, which is phone and email anyway, so it's already giving some time savings even in a non-connected state. And that's where we can then offer the integration on top, which if a terminal has integration options, which most do, that can be done typically in 1 to 2 weeks.
Very good, thank you. Then my next question maybe goes to Jussi. So what players do I need to get started with one of your AI applications? So it sounded like a very collaborative and interconnected approach, the different use cases that you mentioned as well. Is it always necessary to have a, let's say, coalition of the willing, to have a group of different stakeholders within one port or within one area, region, to make this work?
No. Hello? Yeah, okay, it's working. No, not at all. So it depends very much on the solution that we are talking about. So of course, we have like off-the-shelf analytic solutions like global predictions on vessel schedules, and that's dependent only on public data. And we can offer that through APIs to everybody right away. But then, of course, we do a lot of kind of custom work, and kind of like the multi-hop thing requires us to have like regional access, for example, to port call plans. And that's like something that is available in certain regions through the kind of governments and so on. But then, of course, we also collaborate with, let's say, customers who have access to this kind of data all over the world. So that's like, it's a little bit case by case. And of course, we then build completely custom solutions, like where you can kind of define the analytics that you want to have, and then it's more of a project that we just set up, you know, the kind of analytics that are needed.
So a very broad spectrum of approaches.
Yes.
Thank you very much. And then I would say, place my next question to Lasse. You were talking about the different levels of automation, let's say, and I was wondering, is level 5 something we will see in 1 year, 2 years, 5 years? Will we see it ever?
That's a very good question. I didn't emphasize that too much, but I think, as I said in the presentation, level 4 is something that we should be aiming at. Level 5 is a little bit of, let's say, still a dream somewhere in the future, from my perspective at least. And I'm not sure if it's necessary even to get there. So level 4 to me is the target.
And will level 4 be something that is achievable by all types of terminal operations, or is it a specific time of operative setup that can achieve level 4 and others can only achieve level 3? Or
I think we need to just look into the, let's say, the situation where we are and the maturity of the operation in general and how it looks, and then see what is feasible, what makes sense, what is kind of cost effective, where we have the business case. It's not so much about the kind of the level 3 and 4 type of question, but it's more about what makes sense and from commercial point of view as well.
Okay, thank you. I have a look at the audience once more. Maybe there's a question from the audience by now. If not, I will just go along with my own questions.
Maybe I would have a question. So, to Lasse, I was interested to ask, because these kind of digital twins are a big topic also in ports, and I would assume that your robotic solutions would benefit from having this kind of digital representation of the port. So is that something that you do, that integrate these kind of local sensors to these digital twins?
Yeah, it is important, and in a way, if I look at the development that we do right now, for instance, everything actually starts from more like simulation and the model, and how everything connects into that and integrates into that. And of course, we can scale it from the equipment to a kind of whole solution and system level operations and include everything in it. However, I think once again, let's put the effort where it pays off, and in a way, so let's not make it too big to start with. But definitely going forward, I mean, the operational kind of optimization with these new solutions, it's important to validate through different kind of simulation in the first place.
Yeah, maybe little comment, an innovation came to mind. So actually, you could even use your solutions to kind of update and maintain these digital twins. So the sensor information that you get out of the robots would actually feed into the digital twins. So yeah, that's a nice thing for the future. Right?
Yeah, definitely. I mean, the amount of information coming from different types of sensors here is amazing, and I think it was touched also in some of the presentations earlier this morning here. It's not often so much about the kind of amount of data that's available, for sure, but in a way, how to use it in the best way, how to optimize it. I think that's a good idea to kind of look into the different opportunities of using it actually for instance, digital twin applications.
Yeah, thank you.
Please, if you want to have a discussion and pose questions yourself, go ahead. So I was just looking at my questions, and one thing that I noted was you were saying that you're filling the gap between the operators and the carriers. But in my experience, there's also a gap, for example, within the carrier organization. So there might be a delay of a vessel on the way, and until this information is actually in the IT systems or in the hands of the person that is maybe filling the PodChain Connect system, it can take a while. So we have a delay there, and we also have a gap there. What is your experience on that, and how do you believe can we fix this?
It's a really good point, because there's both typically most carrier organizations, a headquarters, a regional and a local team. And systems and different update frequencies depending on which carrier you are. So I think that's really where what we try to do is make something very pragmatic that, of course, it integrates with the system, but it also enables when a frontline user has more updated information, they can override the system information, and everything is tracked. So you can always see what was system, what was user, who made what change, to basically provide one information source so everyone on the same page in that sense.
Sounds good. Thank you. And another thing that came to my mind is when I think about all of your presentations together, it makes sense for, let's say, industry players to not only have one solution in place, one thing that they try to optimize or fix, but to maybe use a portfolio of different solutions. And maybe you can discuss it amongst yourself, or each of you can give a statement. How do these different problems and solutions to the problems that you are offering interlink with each other and maybe give each other additional benefits if you use them together maybe?
I think maybe I can add. I think the key point is that interfaces and you can connect and share data, and I think that's where we as PortChain as an example, we welcome all the developments around standards from DCSA, for example, because that is something that will enable common sharing of timestamps in our case between systems. So you have a common definition, and that'll make system integration a lot easier.
Yeah, I would agree on that one. I think there's different levels that we can look into and different parts in operations that we can improve and should be improved. And then it's all about the kind of having the holistic view into it. And I fully agree that sharing the data through the standard interfaces is already a good starting point for the activities going forward.
Yeah, and kind of you can already see how much work there is because, like, we provide situational awareness which tries to get information for many systems, and still there are more and more systems coming, like the robotics that you are developing, and I think it's a long road to get, for example, information from your robots automatically in a way that everybody could kind of know where they are. Even though that is doable, it's feasible right away, but still, it's just technologically, there are just so many interfaces you need to implement. So it is quite a long road, I would say.
And maybe a never-ending road, since new innovations come along in the next years as well. So I think you have answered all of my most pressing questions. Feel free to add points as well if you have some.
I may have one question actually regarding PortChain. I guess your company is very much driven by kind of solving, let's say, the problem of inefficiency in the industry. Are you measuring that as your key KPI? How much you have been able to kind of deliver in terms of that, or remove that inefficiency overall? Are you kind of measuring that as your key KPI?
Yeah, no, for sure. I mean, there are different, you can say, right, you can measure all that from leading indicators. Can you see the data is getting better, for example? Can you see then that leads to a better outcome, for example, in terms of waiting time? And we can definitely see the hard metrics and the soft metrics, but of course, as we all know, attributing benefits to a one specific thing is always a challenge because every carrier and terminal will have different initiatives going on at the same time. But we, at a macro level, and when we go into the specific leading indicators, we can clearly see a difference.
Yeah, that was actually the reason asking the question. So it's so difficult to kind of point to the actual thing that made the big step in the end. So I think that's a challenge, but good answer. Thanks.
Thanks for the presentation. So one quick question. So my name is Ari Haapanen. I'm coming from a company called EuroDI. We are specialized in this kind of logistics and supply chain integrations. And I guess my question is for Thor and Lasse mostly, that you were talking about the standard interfaces and data sharing. Data sharing, can you hear me? Okay, sorry. So in standard interfaces, and Thor has mentioned also a couple of times DCSA. Do you see that there is already existing data, this kind of standard interfaces, and how this data can be shared between different kind of stakeholders? Or is that something in the future perhaps coming? Especially DCSA, I think it's a good initiative, but I think it's not that widely adopted yet.
So your question is if the standard interface is already there or if they're coming?
Yeah, basically yes.
Well, I think the first implementations of those standard interfaces, or I know that they have been implemented, but I think it's still not widely adopted in the industry. I think there is buy-in from at least from all the bigger carriers, and I hope also on the terminal operators they will also open up for this kind of standardization. So I think it's definitely something that's coming, but not not in the too distant future.
Yeah, I have very little to add on that. I agree on the status of that one. Of course, we have been promoting standardization of interfaces and openness in that as well quite a lot in the past. But I think as an industry we still have room for improvement in general.
So actually, I have one more question myself. So all of your presentations include things like machine learning, AI, things that are not really understandable or visible to the human beings that are working with these applications, also with the automation. Do you include into your product developments the idea of making decisions transparent and also visible to humans, even though that humans might at one point not even it might not be necessary for them to understand the decisions because they are not interacting with the systems anymore, but it might make it more comprehensible to them?
I think that's a very, very important point, and in a way it becomes so complex when the machines are kind of just doing the decisions themselves, and it's very, very important to communicate that decision. For instance, a updated route or path. So how should the other players in the environment understand where the machine is actually going if it's not communicated properly? So for sure, that's a very important aspect of it, and also to the operators who manage the whole fleet. So it is very important to understand. So that's crucial. Yeah.
Yeah, and I think these kind of planning support tools like predicting different things, schedules and so on, and prescribing things, I think the industry is not ready for really fully automating that. I mean, we are far from level 5 or level 4 in that sense on this kind of planning automation. So of course it's more, as I said, an augmented intelligence thinking, that if we are just providing helpful information and trying to get value out of the existing imperfect information for the planning. So then it's crucial to let the user understand where this comes from and what is the reliability and so on.
Yeah, I agree with everything that's being said. I think it's providing the context for the user so they know why is this recommendation being made, but ultimately leaving the user with the power to make the decision, and giving them the data so you can say, okay, option A or B, but they ultimately can make the decision.
Very good, thank you. Any more questions from the audience?
Yes, my question is for Lasse. So Kalmar's main business have always been hardware, but it sounds like you guys are moving into software with the AI and the robotics and stuff. Is that where you guys are going, and what is like the strategy there?
So it was a little bit difficult to hear the question, but if I understand it was about, in a way, are we moving fully to the software side of things in the development, for instance. So of course that's part of it, but obviously, I mean, still we are very much in the business of the hardware, and we have a lot of customers that will adopt automation only after a certain time going forward. So definitely we stick to that, and but absolutely, I mean, software is a key part of this, and we are very much, of course, strengthening our own resources on that side, but also work with partners to make and find the best solutions that fit our solutions.
So you mentioned partners. Like, what kind of partners would you be like integrating with then within the supply chain?
I mean, I was referring more to the development partners that we're working with at this moment. But of course, once the solutions are on the market, there's a lot of integration to the different solutions and systems in the terminals, for instance. I mean, definitely there's still the kind of the TOC systems as well as then some level of, let's say, automation solution that coordinates the activities also in these solutions.
I would say a very, very warm thank you to all of you for your presentations, your thoughts and your inputs. And yeah, I wish everyone a good lunch break, I would say. Thanks for being here, and yeah, thank you also for being here. And have a good day, everyone.